In this video, I am going to tell you what is Thevenin equivalent circuit and Norton equivalent circuit, and this I am going to explain with the help of this simple example, which is problem number 25 in book Engineering Circuit Analysis by Hayt, Kemmerly and Thevenin. Right? So, like if you look at this particular circuit, over here the question says that we need to determine the Thevenin's equivalent network connected to RL. What it means? It means that as per the Thevenin theorem, what we can do, like if I consider only this part of the circuit, if I consider this part of the circuit, so this complete circuit can be replaced just by a single resistance, which is known as RTH, Thevenin's resistance, and a single voltage source, which is represented as VTH, which means Thevenin's voltage, and this is RL, this RL. So what Thevenin theorem says is that the complete complexity of the circuit can be reduced to a simple form where a voltage source is connected with the resistance in series. And now if we determine, the current that is flowing through RL, or the resistance that is across the RL, it will be exactly same for this circuit, as you will find the voltage across RL and the current across RL. So this IL and this current will be same in both the circuit. So the problem is that now to get the Thevenin equivalent circuit, we need to determine RTH somehow and VTH somehow, right? So if we are able to get this value, then the complete complexity of the circuit can be reduced in this form. Now what is VTH and what is RTH? Now to get the VTH, like if I consider this particular example, so the first step is to remove the RL from the circuit. So I will redraw this circuit. So this is our circuit after removing RL. This is 1 ohm, this is 2 ohm, this is 9 volt, and this is 3 ohm, right? Now to get the value of VTH, simply we need to determine what is this open circuit voltage, right? Now using any particular method, we need to determine VOC, means what is the voltage drop across these two terminal AB. Now to determine the voltage, this 1 ohm, it is open circuit, it is in the open circuit part, so no current will flow through it. So over here the voltage, it will be 0 volt. Now we have only one loop, so if I take this loop current as I1, and now if I apply the KVL, so I will get minus to plus. For this I will get minus 9. This current is flowing in this form, plus in the tail, minus over here, so it will be plus 2I1, and then this plus minus, so plus 3I1 equal to 0. So I get I1 equals to 9 by 5, which is 1.8 volt, right? So which is 1.8 volt. Now once I get a 1.8 volt, now I need to determine VOC. Now what is VOC? Now if you look at the VOC, then VOC is like plus is over here. So for VOC we need to consider this particular voltage plus the voltage drop across this 3 ohm, right? So it is the sum of the voltage drop across 1 ohm and the voltage drop across 3 ohm, right? So over here, if the terminals are like this, plus and minus, then it is 0, right? Plus. Now over here, the current in this 3 ohm, the current is coming down, right? And the plus is at the top, minus at the bottom. So this is aligned with this. It is the reason I put plus 3 ohm. Now what is the voltage across 3 ohm? Now the current that is flowing through this 3 ohm, it is I1. It is I1. So the voltage across 3 ohm, it will be 3 into I1. I1 is 1.8. So 3 into 1.8, which is 5.4 volt. So I substitute the value of 5.4 over here. So our VOC, it is 5.4 volt. So this VOC, open circuit voltage, it is our VTH. So our Thevenin voltage, it is simply the open circuit voltage. It is the open circuit voltage across terminal A and B. So what I did, I simply removed this. In this circuit, I simply remove this RL, this part of the circuit. I remove it, and then I calculate open circuit voltage, and this open circuit voltage is the VOC. Why I remove it? Because it is this particular element across which I need to determine the Thevenin equivalent. You can check that in this particular circuit, RL is still there, means this part of the circuit, it is still there in the circuit. Only the left part of this circuit, means this one, it is not present in this circuit. It is replaced, like this part, the part of the circuit on the left, it is replaced with VTH and RTH. So it is the reason that I remove RL. I keep RL as it is in the final circuit, in the Thevenin equivalent circuit, and then after removing the RL, then I determine the VTH. Now after determining the VTH, next is to, like over here, I got VTH as 5.4 volt. Now after that, I need to determine this RTH. Now to determine the RTH, like if I redraw the circuit, the given circuit is this is 2 ohm, it is 1 ohm, it is 3 ohm, right? And this is the circuit after removing RL, right? Let it be AB terminal, right? Now to determine the RTH, what we need to do, we need to deactivate all the voltage and the current source. We need to deactivate all the voltage and current independent. Remember, only independent sources will be deactivated, right? Deactivate all the independent sources. If it is a voltage source, then we will replace it with short circuit. Voltage source will be replaced with short circuit, and current sources will be replaced with open circuit. So simply, to determine the RTH, we need to first deactivate the independent sources. So it means that this particular voltage source need to be replaced with a short circuit. So I will remove it from here, right? And I replace it with the short circuit. Now looking at this AB terminal, I need to determine the equivalent resistance, right? So over here, this 2 and this 3 ohm, they are in parallel, right? So their equivalent resistance, 1 upon R equivalent, it is 1 by 2 plus 1 by 3. So our R equivalent, it is 2 into 3 upon 2 plus 3. So this you can solve your own. So it is 1.2 ohm. So the equivalent of this 2 and 3, it is 1.2, right? Now this 1.2, it is in series with 1 ohm, right? So it means our final equivalent, our equivalent, let me give this as equivalent 1 and this is equivalent 2. So it is equals to R equivalent 1 plus this 1 ohm, right? This 1 ohm. So plus 1. So it is 1.2 plus 1. So it is 2.2. And this R equivalent to which we get 2.2. It is simply our RTH, means the Thevenin's resistance. It is our Thevenin's resistance, right? So our Thevenin resistance over here, it is 2.2 ohm, right? Now it means that in this circuit that we have drawn over here, this RTH, it is 2.2, and this VTH, it is 5.4 volt, right? It is 5.4 volt, right? Now if I want to determine the current that is flowing through this RL, so simply I can determine this IL simply by IL is equals to VTH upon RTH plus RL, right? So it is 5.4 upon 2.2 plus RL. RL is not provided in the circuit, right? But in the second half, now going back to the question, you can see that the first part says that we need to determine the Thevenin equivalent of the network. This we have done. Now in the second part, it is saying that determine VL for RL equals to 1, 3.5. So for different value of RL, we need to determine the VL, right? So this is the formula for IL. Now what will be VL? VL will be this, right? So VL will be equals to IL into RL, right? So substituting the value of IL, this value in this equation, we will get VTH RL upon RTH plus RL, right? So VL is this. Now substituting the value of VTH. Now VTH is 5.4. RL is, we have different values of RL. RTH is 2.2 and RL. So we have this formula. Now substituting different values of RL, like the first value is 1, right? So if I substitute RL equals to 1, then for RL equals to 1, I will get VL equals to 5.4 upon 2.2 plus 1. So for this, the answer, it will be 1.6875 volt, right? And similarly, we can determine the value of VL for other values of RL just by substituting the value of RL over here. So with this, like over here, simply whenever we want to draw the Thevenin equivalent circuit, it simply means that the complex part or the part of the circuit across which we want to determine the Thevenin equivalent, for that we need to determine VTH, we need to determine RTH. And once we get VTH and RTH, then simply we will have this type of the equivalent circuit where VTH and RTH and RL, all the three are in series with each other. And then simply, if I want to determine the current through the RL or the voltage across the RL, that can be determined by simply applying the KVL, right? So this is the solution to this particular question. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.